Hey guys, so today we're going to be looking at outliers, and we're going to be using the interquartile range to sort of calculate what an outlier is. So an outlier is any number which is not consistent with the data set. So, I'm going to be using this data set of temperatures this week. So I was sort of bored and I went out and I collected the temperatures which were on the thermometer, and I did this every day in the morning, and I found that on Monday it was 5 degrees. Then from Tuesday to about Saturday it was these low to mid 20s, and then Sunday it was 41 degrees. So I kind of suspect that on Monday this might be an outlier, because it's 5 degrees and it's not really consistent with the rest of the data. And on Sunday it was 41 degrees, so I think this also might be an outlier. So I sort of suspect that that isn't consistent with the data either, but we're going to use this Iqr calculation method just to check. So if we remember, we had the Iqr was the middle 50% of data, and it was equal to our third quartile value, which is Q3, minus our first quartile value. And there are some shortcuts to calculate these Q3s and Q1s. So we actually have two little handy formulas which let us do it. So Q3 will be equal to our n plus 1 divided by 4 times by 3, and it will be at this observation. So Q3 is at this observation, and Q1 is going to be at the n plus 1 divided by 4 observation. So these are our two little handy formulas to quickly shortcut to the Iqr. But what we'll notice about our data is that it is in this really jumbled order. And if we remember, for our Iqr we needed to have the data in either ascending or descending order, preferably ascending. So what we do is we have to first order our data. So I'm going to say that I know Monday was the coldest day of the week, because I was really cold on Monday. So I know Monday was the coldest. And then we had these middle days of the week. So I think 21 looks like it's the next lowest temperature. And then I had that 2 days of the week. Then was 22. Then 23. And we just keep going through. So are there any numbers lower than 23? Nope. So the next highest will be 25. Then the next highest was Sunday, and that was 41, which was really hot. So we've ordered our data, and now we can just use these formulas to calculate where the observation number is for our quartiles. So to calculate this, we're going to need to know what n is. So n is the number of observations in our set. So n is the number of observations. So to calculate that, all we do is we count the observations which we have in our set. And I'll do that up here. So I just had 1, 2, 3, 4, 5, 6, 7. So our n is equal to 7. And we know that's the case because there are 7 days in a week, and I counted the temperatures for every day of the week. So now what we just want to do is we just want to calculate where these quartile values will be. So for our third quartile, and we know we have our n equal to 7, all we do is we sub our numbers into the formula. So our third quartile will be at the 7 plus 1 divided by 4 times 3 value. So 7 plus 1 is 8, so we get 8 on 2 times by 3, which equals to 4 times by, 8 on 4 times by 3, which is equal to 2 times 3, which is at the 6th observation. So we go through and we find our 6th observation, so we can just count 1, 2, 3, 4, 5, 6. So our third quartile value will be this 25. And we can do the same thing for our first quartile. So we just sub our n into the formula. So we've got our 7 plus 1 divided by 4. And if we solve all this out, we get 8 on 4, which is just equal to the second observation. So we go to our data, 1, 2, 21 is the second observation. So that is our first quartile. So all we need to do now to find this IQR is to sub our numbers into the formula. So we know the IQR is equal to Q3, which is 25, minus Q1, which is 21. So our IQR is just going to solve out and be 25 minus 21, which is equal to 4. This would be 4 degrees Celsius. So that's our IQR. Then what we need to do to work out our outliers is we can use this formula for lower and upper bounds. So we've got what's called the lower upper bounds for outliers. So what this says is that for a lower bound, any number which is less than the IQR minus the lower quartile minus 1.5 times by the IQR will be an outlier. So we can work this out. We can say that our first quartile was equal to 21 and our IQR was equal to 4 degrees. So our lower bound will be equal to our first quartile, which is 21, minus 1.5 times by our IQR. So our IQR was 4. So if we solve that out, we'll see that we get 21 minus 6, which is just equal to 15. So we have a lower bound of 15. So that means any number less than 15 would be classified as an outlier. So we then have our upper bound. So we've then got this upper bound. And this says that any number greater than our third quartile plus 1.5 times the IQR is going to be an outlier. So we can just calculate that. So we know that our third quartile was equal to, up here, 25, and our IQR again was equal to this 4 degrees down here. So our IQR is equal to 4. So if we just substitute these numbers into the formula, we can say that our upper bound is equal to our third quartile, which was 25, plus this 1.5 times by our interquartile range of 4. So we know that our upper bound is going to just be equal to 25 plus 6, which is 31. So any number that is greater than 31 will be classed as an outlier. So then all we need to do to work out outliers is go back to our data. So we're looking for any number which is less than 15. So it's probably easiest to look at our ordered set. And and we can see straight away that this number 5 over here, so this number 5 is less than 15, and this little symbol just means less than. So we would say this number 5 is an outlier in the lower tail. Because the number 5 is less than 15, it's an outlier because it's below our lower bound of 15. Then we can say this 41 here, so this 41 is going to be greater than 31. So we've got no other numbers greater than 31 except for 41. So this 41 is going to be greater than 31, and this little symbol just means greater than. So because of that, 41 is an outlier, and it's in the upper tail. So I was pretty right in my thinking. The 5-degree day was an outlier because it was really, really cold, and then the 40-degree day was an outlier because it was in the upper tail, and it was above our upper bound. So just remember how to calculate your lower bounds and your upper bounds. We've got these two formulas which just basically tell us the upper and lower bounds. So that's how we do our upper and lower bounds. With outliers, they are not necessarily excluded from the data, so we don't exclude them, but what we do is we make a note on the observation, so we might say exclude it from our box plot, and rather than having it within our whisker, we'll have it as a separate dot outside, but they're not excluded generally. So that's how we do outliers, and I'll put some examples up for you guys to have a look at. Thanks guys.